Welcome back to this edition of the APSCC 2020 live webinar series. I'm Christopher Slaughter, your MC for the series. Welcome to today's episode, Satellite Ground Segment Ready for the New Space Revolution. Today's webinar is brought to you by ST Engineering iDirect. We're very pleased to have their support for this installment of the series and for APSCC overall. Joining us today from Euroconsult is Stéphane Chenard. He'll be moderating today's session, which features the CTO of ST Engineering iDirect, Frederick Simons. Pronunciation not my strong suit, but he answers to his name. At any rate, I'm going to leave you now and let Stéphane take over with an introduction, and after that, Frederick's presentation. Thank you all very much for joining.
And thank you, Christopher. Greetings from Paris, France. So usually the debate around new terminals for LEO satellites, which is what we're going to talk about today. It's the ground segment for this new generation of multi-beam satellites that's upcoming. Usually the debate turns around the RF equipment, the flat antennas with electronic steering and whether they will be ready or not, and what different models you can put on planes and boats and so on. Today, Frederick, you're going to tell us about another part of the network, the other layer, the baseband, the banks of modems that in a teleport are hidden indoors behind the antennas. For the non-engineers, what happens at that level may be a little bit less easy to grasp than what an antenna does, and VTI Direct is coming up with new approaches to that part of the network. So, Frederick, why don't we pick this apart and let's hear your story first of all, and then we will reconvene for a little bit of discussion after you're done with your presentation. It's all yours.
All right. Thanks a lot, Stéphane, for this introduction. So indeed, we will be talking today about the ground segment. And as you all know, there's a lot of things going on in our industry. So we call it here New Space Revolution. And that obviously has quite some impact on the ground segment in a sense that we also see a lot of need for innovation on the ground segment to enable all of the evolutions going on in space, but not only in space, also on the terrestrial side. And basically, this picture here kind of shows the topics we're going to touch upon today. So we're going to make a point that the ground segment is really at the center of all the innovations that are going on in space and on the terrestrial side. I will show that the ground segment is really the enabler of all of that. So we have evolutions in the space segment. We have evolutions towards a new ecosystem, which is really driven by everything that happens around 5G. And then there are some what we call innovation enablers that are kind of like industry trends that are not linked to the space industry, but very, very much beyond that, specifically related to virtualization, standardization, and orchestration, where we can leverage a lot of the evolutions that need to take place to enable the innovation in terrestrial side and space side, and we'll explain how that all comes together in the new ground segment. So let's kind of start with briefly introducing these couple of topics. So the new 5G ecosystem, as you all are aware, kind of has kind of a context in the fourth industrial revolution. I'm sure you have heard about that term. And what we see there is, in contrast to what the third industrial revolution was, where really all the innovation came from technology enhancements, we see that in this fourth industrial revolution, all the innovation comes from an increased capability to communicate and to connect the endpoints and the players in that fourth industrial revolution. And so we see there concepts like smart networks, artificial intelligence, and interconnecting all kinds of systems. And that is really driving what is going on now. And you see that a convergence is taking place in all the access technologies, and kind of the 5G is the driver there of that convergence. So we see that 5G is kind of the single technology that kind of enables all of the different access technologies that are out there. And the technology behind all of that is driven by a trend in automation, virtualization, and orchestration. And lastly, of course, the fact that the amount of endpoints really grows a lot. We see a need for scale, capacity enhancement, and then of course also a need for more performance. So that's a bit what happens on the 5G terrestrial side. Similar evolutions are happening on the space side, where we see also a lot of changes in the last couple of years. You all are aware, of course, that the entire space industry is moving from traditional geo satellites to more hybrid mix of geo, MEO, LEO, and even HEO satellites, and also move from HTS to very HTS satellites, so very high throughput satellites, where not only the capacity is increasing a lot, so we're moving from gigabits type of capacity to really terabit level capacities on a constellation level. But we're also seeing that the satellite capabilities are changing a lot. A satellite used to be kind of made to a specific purpose, with beams being designed to cover specific regions, with beams being dimensioned in terms of bandwidth, in terms of megahertz, to provide specific throughput to specific regions. So all of that was in the past pretty much pre-configured and was kind of designed at the moment that the satellite is being manufactured. What we see now is that all those satellites become more and more flexible, and the beams are no longer static, but they are completely dynamic in the sense that the beams are being defined at the moment you need them and not at the moment the satellite is manufactured, which kind of course, opens a lot of possibilities and creates a lot of flexibility for the operators of that satellite. And we'll explain later on what kind of impact that has on their business. And the last point, the fact that we're moving from on-demand payloads to more like standardized payloads nicely fits into that. So the fact that you don't need to design your satellite payloads up front, but you can move more to generic payloads or standardized payloads, then obviously creates some scale advantages. That generic payloads can be launched, and then they are configured to the specific use case long beyond the launch. And so this obviously kind of takes away a lot of business risk for the operators that are launching those satellites. Of course, those innovations that are taking place on the terrestrial side, the 5G evolutions, as well as on the space segment side, have some implications for the ground segment itself. And so you will see that the ground segment, together with the space segment, is moving away from standalone networks. What I mean with that is that typical VSAT systems have always been kind of configured and installed next to all kinds of other networks that are out there. And what we see now is that this needs to blend in seamlessly with all kinds of other access technologies. So that's the first point, that we're moving from standalone VSAT networks to more integrated ecosystems where the satellite connectivity is just one of the many ways to communicate in this 5G ecosystem. The second point is that the ground segment is really moving away from appliances. So basically that means delivering separate boxes to do the modulation, demodulation, processing to more virtual infrastructure, and we'll zoom into what that means later on. And we also see that the ground segment is moving from a paradigm where everything is configured up front to a more orchestrated service delivery, where basically services and infrastructure is created and orchestrated at the moment it is needed, and nothing needs to be configured when a satellite network is brought up. And that, of course, the last point is that the satellite flexibility, and what I call here software-defined satellites, so satellites that are really fully programmable, obviously translates to a need for a fully programmable ground segment to then ultimately create a complete software-defined network. So these are kind of the consequences of the evolutions that are taking place in space and on the terrestrial side, and what that means for the ground segment. So before we zoom into more detail into what all of this means, we're just gonna kick it off with an example to set the scene and show how a future flow or a service order flow would look like, and how that differs from what today's satellite networks look like. So I'll just first illustrate the satellite network and ground segment that we are considering here. So there are different elements in a satellite system. You see on the left-hand side, you see everything related to the operator or gateway infrastructure. And on the right-hand side, you have the remote terminals, and obviously you have the satellites in between there to connect a gateway with remote terminals. And the elements of the gateway, there are actually three main elements. You have first the platform NMS, so that basically the network management system that is configuring and orchestrating the whole gateway, but also the configuration of the terminals. Then you have the virtual core hub module and the virtual baseband hub module, which basically hosts all the gateway processing functions that manipulate the data, the traffic, and that allow to send it over the air. So in the virtual core hub module, you have, which is typically hosted in a data center and can be centralized for multiple teleports, basically hosting all the traffic optimization functions like compression, TCP acceleration, routing. So that's all being done typically at a central location. And then close to the teleport, you will have the baseband functions. So these are the traditional modulators and demodulators. But there's a trend now to also fully virtualize that, in a sense that you no longer have a dedicated modulator device or a dedicated demodulator device to perform certain modulation or demodulation functions. No, instead of that, you have some baseband hardware equipment. And as we will explain later on, depending on the needs or the need to create certain beams or carriers, we will spin up virtual functions on there, and we call them here virtual baseband functions, to then actually create those modulator and demodulator functionality. And then, of course, on the right-hand side, you have your terminals. And then also one important element that is becoming more and more standard, let's say, with those next generation satellite networks is some form of resource controller or global resource controller, which kind of manages the configuration of the satellites, and then also, of course, interfaces with the ground segment to synchronize the configuration of the satellites with the ground segment. So satellites, as I have explained, become more and more flexible in the sense that beams and bandwidth per beam can be configured on the fly, and it's the resource control that kind of programs that onto those satellites, and then also makes sure that at the same moment in time, the ground segment is also programmed to kind of light up the beams and the capacity that is being created on the satellite to make sure that there is an end-to-end connectivity. So these are the elements of the ground segment that are in play, and the example that we want to discuss here now is the example of a customer, and a customer that can be a service operator or even a satellite operator that wants to run a carrier Ethernet service to a number of remote locations. And we'll show the different steps that are being taken to enable such a service on this new ground segment. So again, this is the space and ground segment illustration. And what happens first to enable such a new service is that the customer, so the service operator or the satellite operator, kind of enters a new service order in one of the billing systems or BSSs, OSSs that interface with the platform NMS, and that also interface with the resource controller. And so at that moment in time, that service order will be translated to, in an automatic fashion, to a new satellite configuration, and also to a new ground configuration. So as you have seen at the moment that the satellite configuration is being entered, the satellites will be reprogrammed to put the resources that are needed for that new service. In this case, creating carrier Ethernet connectivity to a number of remote terminals on the right. You have seen that there is a yellow beam being created as a result of that new satellite configuration being put in the system. And at the same moment in time, the ground segment is also spinning up the necessary resources to then eventually enable the traffic running from the gateway to those new remote services. So what you see there is that new network functions and new baseband functions, so which are all virtualized, are being spun up in the virtual core hub module and also in the virtual baseband hub module. And those functions, so the VNFs and the VBFs, are then responsible for moving the traffic from the gateway to the remote terminals and back, and so setting up the end-to-end connectivity between the gateway and the remote terminals. So just to come back, or just to summarize what we have all seen here, is that the satellite is being reprogrammed on the fly, so not up front. It's being reprogrammed at the moment of entering a new service order. And also the ground segment is being created, or the resources at the ground segment are being created at the moment the new service order comes in. So there's not a lengthy process anymore of installing new modulators or demodulators at the gateways. No, there's just a bunch of infrastructure available at the gateway, which is dimensioned typically for a certain amount of gigabits of traffic. And irrespective of the amount of beams or the size of the beams, that same hardware can, by simply adding those virtual network functions and those virtual baseband functions, can just light up new beams and can create new capacity over satellite to a set of remote terminals. So everything going fully automatic, no need to bring in new hardware the amount of resources that is there is placed there up front, and the resources on that hardware infrastructure are being created at the moment they are needed in a fully automatic way. So this is kind of what this ground segment orchestration is all about. It's about activating beams and services on the fly. And well, this slide kind of illustrates what is different in this paradigm compared to what we had before. And before, activating a new service was typically a long and resource-consuming process because it typically involved adding dedicated hardware and configuring that hardware in a manual manner, which then obviously translates in more CapEx, more OpEx, less service innovation because it's less flexible. When you install the hardware, you typically already need to know exactly what you need to what you want to do with it. And well, there was a tighter connection between the service that you had in your mind and the hardware that you install at the gateway. While now activating those services happens fully automatic and also can happen at the moment that the new service is really needed. So the operators are creating those virtual networks on generic infrastructure, which obviously is less prone to human error if this happens in a fully automatic way. So the service configuration triggers all the ground segment modifications or infrastructure generation, and this is no longer a manual process. So that means that it creates much lower risk and certainly a much faster time to revenues and a lot more flexibility over time, bandwidth, place, which means that when you install your ground segment, you are not bound to a specific application or to a specific region or to a specific dimensioning of your network. No, that happens at the moment you really deploy your services, and you basically just automatically adjust your ground segment infrastructure to align with the services you want to run on top of that infrastructure. So that is what the ground segment, or that is the role that the ground segment plays in that whole space transformation. It really is the innovation enabler, in a sense that the flexibility that the new space brings also translates into new flexibility that is needed on the ground segments. So ground and space are much more tightly interfacing today than they were before. So the orchestration, the flexibility that you see on space, you also find that back in the ground segments. And next to that, it not only translates in more flexibility or more need for flexibility on the ground, but it also has a spin-off in all kinds of new innovations that are needed with respect to waveforms, for instance. So if the spacecraft or the capacity that is provided in different beams can vary over time, it also, of course, means that the carriers that are being set by the ground segment need to be able to change over time as well. So instead of having static carriers, there's a need for dynamic carriers, both in the forward and in the return link. So these are like secondary spin-offs of the fact that we need more flexibility in the ground. Another example there is beam hopping, which is also a physical layer protocol that allows to more dynamically divide capacity over a larger amount of beams by hopping the transmitted signals from one beam to another in a round-robin fashion. So the need for more flexibility not only translates to the way you are organizing or setting up your infrastructure on the ground, it also translates to innovation on the physical layer protocols. And then, as we explained in the example, there's of course also an integration needed between the ground and the global resource manager. And typically, there will be an API defined there that allows that the global resource manager that kind of reprograms the satellites to, at the same moment in time, also reprogram the ground segment to make sure that the ground segment is always in sync with the space segment. And all of that, of course, needs to happen in a fully automatic and orchestrated manner, so that there cannot be any manual interaction there when this whole flow of events takes place. So obviously, this brings a lot of benefits for the end user. So we already talked about the fact that it creates more reliability in the business models. The fact that you no longer need to decide exactly what kind of markets or what kind of applications you want to serve at the moment of launch of the satellite, or also at the moment of installation of the ground segment. That is fully transparent to that. Basically, everything is configured or everything is orchestrated at the moment you are actually launching those new services. So it's also adaptive for different verticals. This ground segment needs to be able to cover all the verticals, and that's what the ground segment is able to do today, so that again, you are no longer bound to a specific vertical when installing this ground segment, but you can, depending on how the market and the business evolves, you are able to just reuse that same infrastructure for different verticals. And then, of course, the last point is that you have this flexibility over time, bandwidth, place, meaning that when you see more opportunities in one region and more bandwidth is needed in that region compared to another, you are able to shift that bandwidth not only on the satellite, but also on the ground by just reconfiguring the hardware there, and by the way, also in a fully automatic manner. So basically, to enable the space transformation, the ground segment is going through a lot of innovation today, where we are moving from static configuration to fully dynamic, automated orchestration, and not only on the automation and orchestration side, but it also ripples through to the physical layer protocols and the high layer protocols that are being used for the communication between ground and space. Of course, there's this other trend that we talked about at the beginning, is the fact that the satellite system needs to become part of a much broader ecosystem, the 5G ecosystem, which kind of puts some additional requirements to to what the future ground segment needs to look like. So there are, of course, requirements in terms of scale, capacity, means of communication, or means of kind of applications and traffic profiles. But the most important element is that the ground segment needs to seamlessly interface with all the standardization that is going on in the terrestrial side. So the standardization within 3GPP, but also other standardization bodies like the Metro Ethernet Forum that kind of defines the carrier Ethernet protocols. The ground segment for satellite communication should no longer be a special way to do communication to certain endpoints, but it should rather blend in seamlessly with all the other communication protocols that are in place, being terrestrial broadband access or mobile communication. Satellite communication should just be one other means to communicate within the 5G ecosystem. And for terrestrial operators or telco operators, satellite should no longer be a special case, but it rather should be managed and configured and authenticated and and authorized in a very similar way as all his other terrestrial communications are being managed. To show you what we mean with this, we kind of gonna illustrate this by means of two satellite communication use cases. And the first one we call the use of satellite communication for transport networks. And the second one we're going to call the use of satellite communications for access networks. As you can see at the bottom left of this slide, satellites can be used to connect nodes in an overall network, which can be located more in the core of the network. Examples of that are like cellular backhaul or connecting large enterprises with the internet backbone. So that's the first use case, and the second one is where satellite is really used at the edge of the network to provide like the connectivity to the network endpoints. And examples there are like consumer broadband access, IoT, connected cars, and what we see is that in the terrestrial equivalent of that is that you typically reside to two different protocol stacks where transport networks are typically using carrier Ethernet type of connectivity. And then, of course, the goal of the satellite segment, which is connecting them, in this case, nodes which are more in the center of the network, connecting core nodes and edge nodes. And what we have there is that at the edges of that satellite network, so both at terminal side as well as gateway side, we need to align, or the ground segment needs to align with the control and data plane standards that are in this case coming from the MEF standardization, so the carrier Ethernet standardization, and the fact that there is a connection happening over satellite should be fully transparent to the rest of the network. So at the edges of our satellite communication system, both at gateway and as terminal and at terminal side, we seamlessly integrate with the specifications of the MEF carrier Ethernet standards. So in terms of control plane and data plane, but also in terms of management and orchestration. So as we gave the example in the beginning, if a new service is being configured, the same service flows that would configure the terrestrial network will now also be used to configure the satellite network. So there's a full alignment here between the satellite part and the rest of the network part, let's say. And the same is happening for the access part. So if satellite is being used as an access technology, then of course dominant technology there and on the terrestrial side is 5G. So again, the satellite system will at the edges, so both again at terminal side as well as at gateway side, will also fully interface with the 5G protocols. So this way, operators like telco operators, they can just seamlessly blend in their satellite network in their entire terrestrial ecosystem, and the satellite network is no longer a specific case, but you just configure it exactly the same way as you are configuring your other access networks, and also the integration on the traffic and control plane level is also fully aligned with the other parts of the access network. So that is basically what we mean with how the satellite network or how the satellite system should integrate with the terrestrial or the 5G ecosystem. So this slide kind of summarizes that. So there are a lot of connectivity or types of connectivity within the 5G ecosystem, and satellite is just one of them. And depending for what satellite is used, it is configured and it's dealt with in a completely transparent way compared to all the other access and transport networks that are out there. So that already brings me to the last part of this presentation. So we talked about the evolutions on new space and also on the terrestrial side on 5G and how that puts requirements and a need for innovation on the ground. Now we'll just briefly touch upon what are those innovation enablers that we can benefit from on the ground segment, and that really allow to bring that innovation by just reusing a lot of the technology evolutions that are taking place in all the industries around there, so that we don't need to reinvent the wheel. So we kind of see several elements or several innovation enablers that we are reusing in this new ground segment. Yeah, first of all, on the left-hand side, we mentioned there the standardization that we can fully leverage, and the fact that 5G is specifying how those interfaces and how those protocols need to look like, kind of is something that we can immediately rely upon, and we don't need to invent those protocols and those management and orchestration layers anymore ourselves, but we can just reuse fully what is being defined on the terrestrial ecosystem. And that brings us to the second point, like this orchestration framework, the way new services are being set up. That is something that we don't have to invent, but we can reuse concepts from like the Metro Ethernet Forum, the lifecycle service orchestration standardization that can be fully reused and leveraged also for the ground segment. Obviously, all of this drives upon the fact that the entire industry is moving to full virtualization and leveraging the cloud. So we're moving away from appliances to virtual network functions that can run on public clouds or private clouds, but that have less and less connectivity or less dependency on the specific hardware those network functions are running. And then, of course, last but not least, there are a number of core technologies that we have in-house, like waveforms, cross-layer optimization, the way satellite networks are being managed. And those core technologies, of course, are being adapted to actually bring those flexibilities that we have been talking about. For instance, on the waveform side, we are relying on DVB-S2X, but also the extensions within the DVB-S2X standard that, for instance, allow for beam hopping, or we kind of extended ourselves to allow for flexible carriers. And in the return link, we have our MXDMA technology that also brings that full flexibility where carriers can be resized on the fly in a fully automatic and coordinated manner. So these are just some examples of how those core technologies that we have in our platform can be leveraged to fully bring that flexibility that is needed in the ground to enable the flexibilities on the terrestrial side and on the space segment side. So this kind of, all these innovations you will find back in the different elements of our ground segment, and basically with the goal to then deliver that fully automated, orchestrated, and flexible ground segment platform that interfaces with the terrestrial and the new space segment. So to conclude all of that, we see a lot of things happening in our industry with respect to convergence of 5G and satellite communication, and also new space evolutions. And the answer to that is a ground segment that fully adopts the automation and orchestration that is being standardized on the terrestrial side, that delivers that flexibility in a completely seamless manner, so completely transparent to the end users, that interfaces with a global resource manager that is not only programming the space segment depending on the new services that are needed, but also programs the ground segment completely synchronized with that new space segment, delivers that irrespective of the application, land, sea, air, cellular backhaul, broadband access, and mobility. That platform should allow to be completely agnostic from the application that runs on top there. And then, of course, obviously, it delivers the efficiency, performance, and scale that is needed to really leverage all those new capabilities that are out there, and also the new scale and throughput that is being enabled by the evolutions in the space segment. So that brings me to the end of my presentation, Stefan, and I'll hand it over back to you now for the Q&A.
Thanks, Frederick, and thanks again to all of you joining us. As a reminder, while we are having this discussion, you can also message your questions to Frederick via Slido, and he will respond via the same application in text. So we get 2 Frederick Simons for the price of 1. If that's not virtualization in itself, this is all about flexibility. You've hinted that today satellite networks are not as flexible as we would like them to be. Now let's spend a minute on the way business is done today, just to put into context and to contrast the innovations that you have been talking about. For 20 years, we've grown used to the idea that it's all IP based, it's all bits, it doesn't matter what they are. And if I want at the same time do a video conference over a cloud application like we are doing now, exchange plain text, email, watchcat videos, get sound coming in, send files, PowerPoints in whatever format they are, it's all the same equipment, it goes through the same network. It's transparent to me. I don't have to know. Like we hear at every satellite conference, the end user does not want to know how his communications are handled, whether it's on satellite or terrestrial or through 2 cans with a piece of string. Apparently, satellites are not quite there, right? And you've said, if I want to do a video conferencing between a ship in the Indian Ocean and Paris, I cannot just turn around and say, okay, and now I want to connect a smart car to another application, or a sensor to a server. That at some point in a teleport, there's someone who has to scramble and say, wait a minute, I have to configure the modem. Is that a fair summary of how business is done today? Or are we a little bit more flexible than that already?
Well, indeed, we are, we're maybe a little bit more flexible than that, in a sense that typically satellite networks today, they already have like central configuration. So you can configure from what's typically called a NOC, a network operating center. You can configure modifications to your network. So if you want to create a new satellite network, you can do that by means of configuration, but that's still a bit different from where we want to end up here, is that when a new service is being configured across all the different technologies. So basically the example that you give, if you want to connect a ship to some point in the internet, you not only need to configure the satellite part, but also the rest of the terrestrial network. And basically what we're saying here is that the way the rest of the terrestrial network is being configured should actually also be the way you configure that satellite segment. And so there shouldn't be a satellite operator guy in the middle that in the network management system is entering new configuration. No, that should all flow automatically from the service orders that come in from the OSS, the BSS, the business systems that configure not only satellite part but also the terrestrial part, and those same interfaces should be applied on terrestrial and satellite part, and there's no need for a guy in the middle that kind of translates the end-to-end service into satellite-specific configuration, and that should all flow automatically. So the big difference compared to today is that there's no need anymore for somebody doing some configuration on the satellite part. It should all just interface in an automatic way, and business service orders that are entered in the end user service provider's billing system should eventually translate to a whole set of configuration changes on the satellite segment without any manual interaction.
And no guy in the middle is very much the way that the terrestrial carriers have already been operated since they went to IP, right? So the satellite networks are catching up here.
Yeah, and this is of course to a certain extent also driven by the fact that satellite systems were always a bit more static than terrestrial systems, and because you have those satellites with fixed and specific configurations, that they have certain beams, they cover certain regions, but those beams might not be where the actual traffic needs are, and so they should be able to be configured on the fly, which also means that the ground segment needs to be able to be configured on the fly. And we also don't want any manual guy there in the middle, kind of configuring both satellite segment and ground segment and keep them in sync. No, that also should happen fully automatic, depending on the traffic needs or depending on the service orders that are being placed.
Exactly, and so this is very much driven by this new generation of satellites that are coming, for which there is no coverage map anymore. That was the start of the discussion on new satellites with satellite operators. Show me your coverage. There is no such thing anymore, because anything pretty much pole to pole, any point in the world can be covered at the parameters that you require. Now, those new satellites that are coming up, which include SES O3b mPOWER, not the only ones, the Intelsat EPICS, where they were the forerunners, the Viasat satellites, all of those footprints made of tiny honeycombs of tiny little beams. The user terminals and the user networks and the teleports as they are configured today, can they use those satellites, or would it just break down? Or would they have to invest in hundreds of thousands of modems to cover every possible permutation?
Well, the short answer is that, of course, they can be used over those satellites, but to fully leverage all the flexibilities that those new satellites bring, some innovation is needed on the ground segment. Of course, the good part is that the way we want to do this is to make sure that people that have a satellite system today, that they can simply or easily migrate to, let's say, the future satellite segment, so it doesn't have to be a forklift upgrade. So we're kind of bringing in those new innovations with respect to service orchestration and automation. We're bringing them in gradually, and we have the advantage that the installed ground segments that are out there today are already virtualized to a large extent. So it's basically just creating an additional flexibility layer on top of the already present virtualization to kind of allow more to dynamically create and destroy those virtual network functions and those virtual baseband functions. So in short, there is almost a full reuse of the installed base, but we're just talking here about of the installed base hardware, sorry. But we're talking about just creating new software releases on top there that will allow to deliver that automated flexibility that is being offered by those new satellite concepts.
That's an important point to make, because it's one thing to change the space segment. All you have to do, so to speak, is to launch additional satellites. It's an almost instant change of infrastructure, but all of the legacy equipment, all of this capex, all of those business arrangements with existing teleports do not have to be done to avail of those new capabilities. At the same time, looking at this from the market standpoint, so it's almost infinite flexibility at our disposal. Not everybody needs infinite flexibility. If my traffic stays contained within the same fixed number of beams, because my business doesn't move around that much, that's all. I have VSATs on top of 10 supermarkets and they are not moving around. I don't really need to change anything, right? It's your maritime, your aero users who use through dozens of beams already who will be first to benefit of this. And then, of course, there's not that many businesses that stay always within the same 500 kilometers. And as those beams become smaller, also, it's a really small country that will be covered by only one or two beams of those satellites. How do you see this from? How do your end purchasers see this from the standpoint of how flexible their own businesses are?
Yeah, so indeed, some of the use cases or some of the customers have more need for this flexibility than others. But there are some commonalities, of course. So even if you have a relatively static business in the sense of that your traffic is known in which beams it will be, and you are really focusing on one specific application, you always still have the fact that networks typically grow over time, and so this technology also allows to expand your networks easily and kind of take away the need that if you just want to add an additional 100 megahertz of capacity to your network, that you again have to install new modulators, new demodulators. So it's not, in this case, not about changing it multiple times a day, the configuration of your network, but still the expansion also happens a lot faster than it happens today. And so there's no need to kind of schedule weeks up front in the next network expansion. No, it's just triggering some configuration flows, and all those new bandwidths are made available automatically.
And then your traffic is known is a little bit an expression of the past also. Because just taking the example of this cloud-based video session that we're having, who knows where the bits go through, how many data centers they touch before they complete what looks to us like a relatively simple point to multi-point network, right? It's the more cloud-based, the more unpredictable the routing is. There's actually some other trends in the VSAT market as well. One is that the enterprise market is increasingly turning to VSATs for backup. And there you cannot predict where you will need the satellite link because you cannot predict which part of your network is going to fail and when or for how long.
Yeah. And by the way,
in the world also where long-term commitments are not good business sense anymore.
Yeah, correct. And by the way, that's also why you see that this ground segment is being split up in different parts, where you try to centralize as much as possible the processing to a central location, so a central data center or so, and that at teleports you typically want to minimize the equipment there to also give more flexibility on where you want to link up your services from. So switching from one teleport to another is much more easy if the equipment is fully centralized and not placed at the teleports. So that also enables that indeed you don't need to know where your bits need to go, on which teleport they need to land. This new way of organizing the ground segment fully allows for that.
This is maybe another useful point to make, because all teleport operator friends are aware of this, but the teleports make money out of hosting equipment and out of managing networks, and but this greater flexibility would make it easier to put those nodes in the network. It's not making them unnecessary. On the contrary, makes it easier to bring them into a network.
Yeah, indeed. So I think the core business of those teleports is really to provide the uplinks and the downlinks to the satellite. That's really where the core added value is. And whether those network functions are really hosted at the teleport itself or at a more central location, I think it only adds to the overall flexibility. The fact that it's easier to switch from one teleport to another. And by the way, by switching from one teleport to another, it also means between, for instance, primary and backup sites. So that's also an element at play here, that those services have more and more stringent requirements on availability. It also means that you can no longer rely on a single up and down link location, but it must be possible to switch in an easy way from one location to another, and that of course becomes easier if the network functions and the ground segment functions are placed at the central location and not directly at the teleports itself.
Let's address the 5G part of this, because now this is a technology that could really put anything into the network. You can have in the same pipe a big video stream, data from smart cards, a million tiny bursts from IoT devices that are measuring electric consumption or whatnot, and all will have to be routed and decoded in harmony. Today, would satellite networks run into problems if 5G were plugged into them?
Well, run into problems, not so much, because I mean, some satellite networks are, like I explained in the presentation, are used for many purposes. It can be used as a transport network to do backhauling, which is kind of like agnostic about which traffic runs over there. But they are not, let's say, fully integrated in the 5G ecosystem. So the satellite links are still typically managed independently from all the other parts of the network. And what we mean here with that integration is that, for instance, your billing system or your authentication system that you use for your terrestrial site should not be different than the one you use for your satellite segment site. So it's about aligning on the management, configuration, and control interfaces that the satellite system offers, and aligning that with those same interfaces of the rest of the terrestrial network, so that the higher layer management business systems and management systems can just configure and orchestrate those two parts in a very similar way. So satellite is no longer specific or special case. It's just one of the many transport or access technologies that you have in your terrestrial network.
And so apart from a satellite network today being expected to use some specific protocols which would become less siloed or unnecessary once we have this level of homogeneity that you've described. Apart from that, there's also the expectation that the traffic patterns have to be a little bit predictable, whereas we're coming into a world where they might not be, where they might be extremely bursty, and that would be more difficult to anticipate and to plan for. There's a large community that VTI Direct is actually getting more and more interested in, and that's been the key customers to satellites. That's the video broadcasters. I'm wondering if they still have some specificity specific needs that you have to take into account, or if they become also one more fish in the ocean for the networks.
I think you've also mentioned it a few times. That entire industry is also, of course, fully moving to IP. You have the OTT trend. So it is also converging, let's say, much more to the other services or the other markets that run on such a platform. There is typically, of course, the traffic profiles are different because there's typically a lot more multicast type of communication. Although with the advent of the OTT, this is also changing. So it's becoming less and less specific, and it becomes more and more easy to integrate it in a single satellite communication system that enables all types of IP connectivity, and broadcast is just one of them.
Well, absolutely. The broadcasters don't want to be treated differently. They want to be one more fish in the ocean because their customers have made it clear that this is how they want their service to be delivered. Now, one key parameter in the discussion on 5G every time it's in the same sentence as satellites, it's always latency. That's the fact that the signal when it goes through a satellite in GEO incurs about 700 milliseconds of latency, makes that communication look different to the terrestrial networks. And there, the debate on whether that's a definite problem for GEOs and they are doomed, or no, it can be accommodated by spoofing, and whether some applications are more affected than others by this, a lot of that is resolved in the baseband at your level. What's your perspective, and would those problems go away a little bit more, irrespective of whether the satellites are GEO or not, because the GEOs will stay with us for quite a few more years? Is that mitigated to some extent by the fact that the networks become more flexible? Does it become an easier problem to tackle, or maybe does the problem completely disappear?
Yeah, well, latency is of course an interesting topic by itself. Well, there are a number of points. So first of all, we have a tradition in the satellite communication industry to try to mitigate as much as possible the impact or the effects of latencies. And so we have all kinds of acceleration protocols built into our stack, so that, for instance, if you do internet browsing, or if you want to transfer large parts of data or high throughput data over satellite, that you're not hampered by TCP protocols that kind of go to a lower throughput or to a slower reaction time because of the long latency of the satellite in between. So that is being dealt with by traffic optimization technologies, which are built into our systems. So that's one thing. But obviously, yeah, there are certain things, of course, that you cannot compensate. So if you, for instance, want to have a very rapid interaction Just one of the examples that is always used is the example of trading, so automatic trading algorithms that want a very rapid connection, for instance, between stock markets in Europe and in US. And of course, if you want to create that connectivity over a geolink, then yeah, you will always encounter that latency, and you cannot compete to connectivities that don't have that latency. But that's then, of course, where new satellite constellations can come into play, and actually can become an advantage compared to terrestrial communications because connectivity from one side of the ocean to the other side of the ocean over a LEO network can actually be a lot faster than doing that communication over transatlantic fiber lines, for instance. So I think the satellite industry there is also evolving in the sense that it can even make latency come to its advantage, or can create a differentiator around latency rather than a disadvantage. So I think it's a mixed story. So we on kind of traditional geolinks, we have all kinds of mechanisms in place to compensate for the effects of latency as much as possible. And where it's not possible, there are alternatives to geo. And then we're coming more into the MEO and the LEO area, where obviously those effects are not in play.
Okay, so it's a lot of exciting stuff to look forward to. The satellite industry sometimes is accused of being a little bit passive and not innovative enough, and still sticking to its guns. Not true, as we've seen. In some cases, it's probably ahead of the wave of innovation by the terrestrial carriers and equipment vendors that define things like the 5G standards. We'll see how we get to play with this infinite flexibility that you are delivering. This is about the end of the hour that we wanted to use. I have no doubt that the questions are raining on you through the text application. Christopher, back to you.
Stefan, thank you very much, and thank you very much, Frederick Siemens from ST Engineering iDirect, the CTO of that company. Also, thank you very much to ST Engineering iDirect for support for this particular webinar. We're very happy to have your support and your participation. Thank all of you for joining us for today's session. We look forward to having you with us again next week. Thank you very much.
Goodbye. See you next week.
Bye.